over this warm-up. Martha is 66 inches tall, and her daughter Heidi is 33 inches tall. So I went ahead and sketched a nice, I didn't sketch a picture, I grabbed some clip art of a picture. So Martha is 66 inches tall, and her daughter is apparently half of her height, 33 inches tall. Who casts the longer shadow? Martha when the sun is 80 degrees above the horizon, 80 degrees, or Heidi when the sun is 40 degrees above the horizon. So obviously when the sun, when that angle is bigger, like 80 is bigger than 40, when that angle is bigger, your shadow is going to be shorter. When the sun's right above you, you almost don't have a shadow, right? But as the sun starts to set, your shadow gets longer and longer and longer. Now, Heidi's angle is greater, so her shadow should be shorter, but she's a taller person. So we're going to use Trig to see. You see the resemblance. So we're going to use Trig to see whose shadow is long. So what trig function are we going to employ to solve this problem? Yeah. What are we looking for? Where's x? Where's the variable? I'll do m for Martha and h for Heidi. Shadows always fall on the ground. I mean, I guess they could fall on the wall if the light's behind you. But anyways, we're going to look at shadows on the ground. They're not ever going to be the hypotenuse. The shadow would never be the hypotenuse, okay? So yes, these are absolutely tangent. So tan of 40 equals opposite over adjacent, and tan of 80 equals opposite over adjacent. Largest is closest. Good. Denominator divide. Both of these are in the denominator. So Ganesh, tell me Heidi's shadow. Relina, tell me Martha's shadow. And Eric, tell me who wins and by how much. 39.33. So, who is the winner? By a lot. This isn't even close. The angle of the sun wins. The height does not win. The angle of the sun wins. Heidi is the winner, and Eric is telling us by how much? Eric, how much did she win by? How many inches? 27.69. So I need to make this problem, I need to make it a closer race, right? Heidi wins by a long shot, 27.69 inches longer of a shadow. So the angle of the sun makes a much larger difference than the height of the person. That's the moral of the story, because did you notice how the height is exactly 1/2, 33 is half of 66, and the angle is exactly 1/2, 40 and 80. But the angle made the bigger impact than the height. All right. Oh, I didn't mean for these to come next. Let's do our homework answers next. Wrong thing. So, last night you were supposed to do page 1 of the Trig Applications. Today I'm giving my students page 2. All right, some people were confused by number 1 only because they didn't understand what a crane looked like. So maybe you need to Google what a crane looks like. But a crane has like this, and then it has an arm coming off of it, right? And then it has a little string with a hook on it, okay? So that's a crane. So it's a 110-foot crane. So where do you put the 110? This is the crane right there. That's where you put the 110. A lot of people didn't put it on the hypotenuse. Set to an angle of 46 degrees with the ground. Can raise a building material to what height? So it's going to pick up the building material, it's going to raise it up. So that's where our x goes. So this one would be sine of 46 equals opposite over hypotenuse. 110 times sine 46. Okay, next problem you were asking about is number 9. A ladder leaning against a house. So you don't ever need to draw actual pictures. It is not a requirement to be good at doodling in this class. But, sorry, I was looking at what you were typing. But start with a right triangle. Every time you can start with at least one right triangle. So we have a ladder leaning against the house. So this would be our ladder, and this would be our house. It makes an angle of 60 degrees with the ground. Is it really 60? We don't have to use trig on this one, huh? The foot of the ladder is 7 feet from the foundation of the house. So, the foot of the ladder, when you hear foot or base, that's the bottom. That's where you put that information. And then it says, how long is the ladder? So this would be your x. I mean, honestly, guys, there's no need to use trig on this one. This is 30, 60, 90. The 7 is across from the 30. And so this would be 14 feet. Don't use trig unless you have to. Because trig sometimes gives you, well, never mind. This one would give you 14. So, easy money. Yep. Number 10. 10 was the only difficult problem on this whole sheet. 10 was the only problem where you have more than one triangle involved. So we have an observer at the top of a lighthouse. So just pretend that's our lighthouse. He sees 2 boats approaching. Just make it a little bit. Okay. One behind the other, the angles to the boats are 39 and 25. The further away you get, the larger the angle is. Oh, sorry. The further away you get, the smaller the angle is. So the 25 is going to go here. The 39 is going to go here. And we need to find the distance between the boats. This is just like the problem we had yesterday with the cars approaching. So we know this value is 50, and we cannot find x directly. We're going to have to find the base of the big triangle, the base of the small triangle, and then we're going to subtract them. So, first I will find the larger one. First we're going to find this. I'll call it A. Compared to the 25, we have opposite and A for adjacent. I'll just keep my A there. Okay? So this is going to be tan. Tan 25 equals opposite over adjacent. And then if we call this value right here, call it B, we would be using this triangle with the 39. This is still opposite, and B is adjacent. So it's tan again equals opposite over adjacent. So you can literally go to your calculator and do 50 divided by tan 25, close parentheses, minus 50 divided by tan 39. You can put it all in one row in your calculator if you don't want to do it separately. And I came up with 45.48. So x is 45.48. So we found A, we found B, and we subtracted them, A minus B. Cool? Okay, suppose you've been assigned to measure the height of a local water tower. Climbing makes you dizzy, so you decide to do the whole job at ground level. From a point 47.3 meters from the base of the tower, you find you must look up at an angle of 53 degrees. How tall is the tower? So what I've said time and time again is to start yourself out with a right triangle. You are 47.3 meters from the base. When you hear the word base, you should be putting these numbers at the bottom, base. You look up at an angle of 53 degrees. This is you looking up. See, this is like your line of sight. You're looking up at an angle of 53 degrees. How tall is the tower? This is the tower right here. So you have to put all your values in the correct spot to even begin to solve this correctly. Okay, so we have opposite and adjacent. You'll notice with real-world problems we use tan a lot. Tan of 53 equals opposite over adjacent. X is in the numerator, so in our calculator we always put the side first. We never put the trig function first. So 47.3 times tan 53, I'm running out of room, sorry about that. 47.3 times tan 53. So if you got it wrong, do you know what you did wrong now? Your cat is trapped on a tree branch 6.5 meters above the ground. Your ladder is only 6.7 meters long. If you place the ladder's tip on the branch, what angle will the ladder make with the ground? So we start off with a right triangle. The cat is stuck in the tree. We are on the ground. I'll put Y for you. You're on the ground. This is the ladder right here. The ladder is diagonal. Okay. The tree branch is 6.5 meters above the ground. So the 6.5 goes here. The ladder is 6.7 meters long. The hypotenuse should always be longer than the leg anyways. What angle will it make with the ground? Well, that's easy to know where to put it because this is the ground. This is not tangent this time. We have opposite and hypotenuse. And so we have sine of x equals 6.5 over 6.7. We do inverse sine, and then we simply type that ratio in. 6.5 divided by 6.7. We round to a whole number, and so that angle is a 76-degree angle. Pretty steep. That ladder is pretty steep. Here's our next problem. A car drives up a slope of 8 degrees for 30 feet, and then at a slope of 11 degrees for 25 feet. How far has the car climbed vertically? Okay, there's multiple ways that you can draw this picture, but just think about, it's a car in San Francisco, and they drive up a slope, and then maybe it levels out for a while, but then they drive up another street. So that would be how this would be real-world applicable. Or what about a parking garage? You drive up a ramp, but then you stay horizontal for a while, and then you drive up another ramp. I'm not asking how far the car drove. I'm asking what height the car is at, vertical distance. So we have the ground. Let's make this the ground. We have the car. They're going to drive up a slope. It's actually a very small angle, but I'll make it larger just so you can see. So they drive up a slope. Just for the picture's sake, I'm going to pretend that they level off for a while, and then they drive up another slope. That way you won't get confused. Okay, so this first one, they drive 30 feet at an 8-degree angle. This second one, they drive 25 feet at an 11-degree angle. And then we want to know this value right here. We want to know the vertical distance. How far is that car off the ground? So what we're going to do is we're going to find A, and we're going to find B, and then we're simply going to add them together. Okay? So we've got opposite and we've got hypotenuse. Sine of 8 equals A over 30. And sine of 11 equals B over 25. Where is the variable? It's in the numerator. So we're going to do 30 times sine of 8. You always put the side first. 25 times sine 11. Guess I'll do that. And then you simply add those two values together. You should get 8.95. 8.95 was the answer. How far has it climbed vertically? From a point 100 feet in front of a public library, the angles of elevation to the base of a flagpole and to the top of the flagpole are 28 degrees and 39 degrees respectively. The flagpole is mounted on the roof of the library. Find the height of the flagpole. I'll help, first of all, with the picture, but I won't label anything. That way people who are just sitting there stuck can have some help. So we have a public library, and on top of the library we have a flagpole. Pretend that that was perpendicular. Sorry about that. You can be right here. There's you. The angles of elevation. Okay, so you see, I'll go from the ground. You see the bottom of the flagpole, and you see the top of the flagpole. So you'll have two right triangles here. Two right triangles. You'll have two different angles. This will be one measure, and this will be one measure. Like they said, you're going to find A, you're going to find B, and then you're going to subtract them. Did that help you set it up? Why is it on top? There's flagpoles on top of buildings. Don't question modern architecture. So the angles are, let's see, this one is 28, and this large one is 39. We are 100 feet away, so this is 100. Both of these are going to be tangent. So the tan of 39 equals, opposite would be A over adjacent. And then you would do tan of 28 equals, this time it's going to be B, opposite over adjacent. Both times you're going to multiply. So you would do 100 tan 39. You're going to do minus 100 tan 28. It's really not that bad once you get the picture going, right? The final answer was 27.81. The final answer was 27.81, what is it, meters? Feet. 27-foot tall flagpole. Oh, you do it without the picture? Well, good for you. Way to go.